Okay, in this question we need to use Pythagoras' theorem to find the short leg or the short length on a right angled triangle. Now notice we're given the hypotenuse, so we know what the longest side is. So Pythagoras' theorem says the square of the two short sides, so 8 and x, is equal to the square of the long side, 13. So let's write that down. We know 8 squared plus x squared must be equal to 13 squared. Now all we need to do is rearrange and solve this for x to find the short leg. So let's work out these squares first. So 8 squared, well we know that one's 64. And we'll leave the x squared as it is for now. And 13 squared is 169. Now hopefully you can see now we need to do a subtraction to isolate this x squared term. So we need to 169 minus the 64. So that will leave us with x squared equals 169 minus 64, which is 105. Now obviously this short length can't be 105, we need to do our square root. So let's square root that and grab our calculator here. So the square root of 105, that turns out to be, to one decimal place, 10.2. So x must equal 10.2, and that's meters to one decimal place. Okay, here's one for you to have a go at. Pause the video, and then when you're ready, see if you get the same as me. Okay, so by Pythagoras' theorem, we know that 19 squared plus x squared is equal to 23 squared. Now working these out then, so 19 squared, I don't know that one off by heart, is 361. Leave the x squared as it is for now. And then 23 squared. 23 squared is 529. Now we need to isolate the x squared. So subtract 361 from 529. That gives us x squared is equal to 168. And then finally we need to square root both sides to work out what that short length is. So the square root of 168, put that into my calculator. And to one decimal place, that becomes, well, it's an interesting one because it's 12.96. So that's actually going to round to 13.0 to one decimal place.